Hi everyone, my name's Sam and welcome to another episode of a show on this channel I simply call Technology. A show where I show you anything technology related, whether it be old or new. On this episode, I'll be creating some custom DIY front upper arms for this HSP RC car. In a previous episode, I created some custom DIY stainless steel skid plates. So if you like this type of creative content, you might also like to watch that video too. This video will use a different format than previous videos I've created. Okay, let's get right into designing and creating these DIY front upper arms. This is the RC car that I will be modifying. It's an HSP Xstr Pro that has already been substantially modified, with aftermarket oil-filled shocks, sway bars, upgraded motor. I'm also using steel pinion and spur gears. I have also completely sealed the gear housing by gluing some bike tire rubber around the inside. This helps to keep out small particles of dirt and stones. These cars are a mid-range budget RC car. From my experience owning this car, it has been quite decent. However, there is one thing that's really quite bad and causes these cars to have poor steering stability. And the reason for that is this. As you can see, there is a lot of play in the lower front arms, not only horizontally but also in the rotational Z-axis. The main cause of this play is this front link arm. It is only connected by two link balls and allows the steering mechanism to move all over the place. This is the reason why these cars have such poor steering stability and are basically uncontrollable while sliding in and out of turns. So my idea is to use these M3 62mm hex socket bolts to create some upper front arms. I have made a cardboard template of what I would like to make out of aluminium. I should be able to use the current link arm and screw that into the upper front arm that I create. I have also created another template that will be used to create a back support for these 62mm bolts that will hold everything securely in place. In order for this upper arm support to work, it will need to be screwed into the aluminium radio tray. The holes that I drill into the support will need to have a slight angle. There also needs to be enough space between the front shock tower and the upper arm support. The parts I will be using for this project are these M3 4mm grub screws, M3 3mm stainless steel nuts, M3 12mm hex screws, and M3 62mm hex socket bolts. I start by cutting the ends off the M3 62mm hex bolts. The reason I'm cutting the ends off is because they're not needed for this project, and I intend to secure the ends and the upper arm support with M3 grub screws. Next, I remove the burrs from the bolts. This is always a good idea to dull down the sharpness. Hi, thank you for watching so far. If you like this video, give it a thumbs up and also consider subscribing. This will help my channel grow and reach a larger audience. Making these videos is a lot harder than I thought it would be, so I really appreciate the support. Thank you. Next, I trace around the cardboard template onto the piece of aluminium. Then I place some copper vice plates into the vice jaws. This is so that I don't put jaw markings on the aluminium. I then place the aluminium piece into the vice and begin slowly cutting. I take my time with cutting and I just let the blade do all the work while I try my best to keep it straight. I finish cutting the part out. Then I file the small angle off the left and right bottom of the part. I also file off all the rough edges. The next thing I do is put the cut down M3 62mm bolts into the shock tower so I can get an accurate measurement of the distance between them. I have put some rough markings of where I want the holes to be. Now I use a center punch tool to mark exactly where I want the holes to be drilled. Here I place the aluminum upper front arm support roughly into the location where it needs to go, and you can see the angle that the holes will have to be drilled on. I use a pen to mark out the angle. Next I place the upper front arm support into a mill vise so that the lines I drew are vertical. Now I place the mill vise onto my DIY drill press. This is a drill that would normally be used in your hands. However, I have modified it to take a 12-volt source, and it's strapped in place with cable ties and small wooden wedges. I just realized how terrible this looks on camera, but it drills straight holes, and it's all I have to work with at the moment. The first thing I do is drill a small pilot hole through the aluminium. Then I proceed to drill through the pilot holes with a 3mm drill bit. I use a file to deburr the holes, and here is the result. Next I start to remove the radio tray. You can see some basic markings of where I would like to drill the upper arm support mounting holes. However, these are not necessarily exactly correct. They are just an estimation. Then I use a small rule to measure the distance between the top edge and my rough markings. I use some calipers to get the exact measurement. Then I use a scriber to mark the diagonal lines. Now I use a small rule to mark out the horizontal line. The spot where these lines intersect is where I will put the center punch. Now I carefully line up the tip of the center punch with the intersecting lines that I scribed. Then I make the center punch that I need. And here we are, they should be exactly the same distance. Next I place the radio tray onto a piece of wood and proceed to drill the two holes with the drill press. I start by drilling two small pilot holes, then I increase the drill size to 3mm and drill through again. Now I make sure my holes have the correct spacing, but if you will remember, I did measure twice before I drilled these holes, and it's nice to see that they are drilled perfectly. Here I am measuring from the center of each hole. Now I cut the threaded end of the 62mm M3 bolt down to the correct size, and then I file the tip of the threaded end just enough so that I can fit the nut over it. So here I have the upper front arm support in place, but unfortunately, as you can see, it's not on the correct angle because I didn't drill the holes correctly, and what I discovered is that when you try and drill an angled hole with a drill press, you get something called drill walk. It's where the drill bit moves on a different angle. After drilling the hole, I did a little research and discovered that I could use something called an end mill bit. The end mill bit can be used to start the hole by creating a flat surface, and then you can easily drill through on the angle that you want. However, I recently purchased a 3D printer, and this got me thinking, could I 3D print something that would do the same job? Keep in mind that I have only just built the 3D printer, and I don't really know too much about it, but let's give it a go anyway. In no way am I implying that 3D printing is better than fabricating something from metal. It's just that in this situation I don't really have the tools required to make the parts that I need accurately enough. I start by opening Blender and configuring it to work in millimeters. I learned how to configure Blender to use the millimeter scale from a channel called Maker Tales. A link to the video that I followed will be in the description. I'd like to point out that I'm using Blender because I've got years of experience using it. Keep in mind that Blender is not a parametric modeling CAD software. It is designed to create 3D objects for games and animations. However, Blender can still be used to create objects for 3D printing and is extremely flexible. If you try to use curves and booleans and keep regular copies of what you're working on, it can be very good. I will also say that if you're someone who wants to take CAD design seriously, then I would highly recommend that you start with one of the many parametric modeling solutions available. But if you just want to have fun and design something to 3D print, then go with Blender. Just keep in mind that the terminologies and modeling techniques between Blender and CAD are completely different. I create a basic cube, then I add some cylinders and start to build up the rough shape that I want for the upper front arms. I then use the grease pencil to mark out some basic areas that I would like to remove. I then create the Boolean objects that will be used to create the weight-saving cutouts. And here we go. The part seems to be modeled quite well. I export this as an STL file. Next, I load the arm into Cura and attempt to set it up for 3D printing. Keep in mind that I am still very new to 3D printing and slicing software, and I set it up the best I can. I'm not really sure if this is going to work, but there's only one way to find out. After I design the upper front arm, I start work on the upper front arm support. I'm not really sure if this is what you call it, it's just what I'm calling it for this video. If you know what the proper name is, let me know in the comment section below. I model this by cutting out parts of cylinders and merging and joining vertices. I also use some other mesh pieces to make measurements. And just like the upper front arms, I make use of booleans to cut out the holes. Once I'm happy with the design, I load it into Cura and slice it. I start the printing process and everything seems to be going okay. And no, it fails. But I know why. It was because my brim and support material was all in the wrong place and possibly not even required. Here is some of the time-lapse printing the upper arm support. And here is the result. Even though it didn't work, I still treat it like it was a success. I think that the overall hole for the 62mm M3 bolt is too small. I also noticed that the upper front arm is a little too long and doesn't give me any ability to adjust the camber. So I take what I have learned from this and make some improvements. Here is the result of the upper arm support that will be mounted onto the radio tray. It turns out that the holes on the 3D printed part don't quite match up, and with it installed on the car, I can see that there needs to be an angle on the front face of the upper front arm support, so I will be making some adjustments to this too. To fix the upper front arm model, I increase the size of the cylinders. I also spend a bit of time working out the measurements so that they are a lot more accurate. Then I load it up into Cura, and this time I set up a support blocker so that no material is created in the cutout areas. I also make sure that the brim is going all the way around rather than just on the end. Now for the upper arm support, I make some adjustments to the angle of the holes that will support the end of the 62mm bolts. I also make the holes on the bottom a bit more accurate. I then make the Boolean object that can be used to cut an angle on the front of the upper arm support. I load this fix into Cura and export it. So I get these printed and they seem to work better. Here are the results of the upper front arm, and this is the result of the upper front arm support. As you can see, they have turned out quite well. I also printed a second upper front arm. I actually mirrored the upper front arm before I exported it, but it turns out that they are exactly the same object and there is no need to mirror. I tap the thread in the upper front arms using a M3 die tap. This is where the turnbuckle will screw into and still allows me to adjust the front camber. I also drill out the 3mm holes to make the M3 64mm bolts fit. I have since learned that you can change the horizontal expansion setting in Cura to have things print out more accurately. Next I tap the bottom holes for the upper front arm support using the same M3 die tap. I also do the same thing for the holes that the M3 grub screws will go into. And here we have it. The parts are all installed. As you can see, it's a very smooth movement, and it does actually solve the problem with all of that play in the front steering. There is just a slight movement from the link ball, but this should be okay. I will add that I'm not too happy with how thin some of the edges are, and I decide to change it to just a single hole in the middle of the upper front arm rather than the complex ones I have now. This time I print with grey PLA+. It's a lot stronger than normal PLA, but has around the same heat tolerance. I also decide to lay them out on an angle in cure, as this is most likely going to create the highest strength parts. So I set this up to be printed, and while that's printing, I do something that I've seen done numerous times on YouTube. It's a way of strengthening the RC car body using shoe glue and fiberglass tape. As you can see, there is a crack in the front of the body. Keep in mind that this particular Lexan body is around 12 years old at the time of this upload, so I've looked after it quite well, and it's time to give it some extra strength so it can last well into the future. I start by laying down some fiberglass tape into all of the areas on the inside of the body. I cut and trim some of the tape so that it fills in all the spaces. I then put on some rubber gloves and begin to spread the shoe glue around the inside of the body. I also use a small paintbrush. Note, I was able to clean the paintbrush with some turpentine once I had finished. And here is the result. Quite nice, I think. They have finished printing, and I spend some time removing the support material. I also tap the 3mm thread and also print out the upper front arm support in grey PLA+. And here they are, all printed out. As you can see, I went with a single hole in the centre of each arm. Here are all the parts laid out, ready to be added to the car. I've also added 2 extra brass washers that will go just before the M3 12mm hex screws. Next I begin to put the whole vehicle back together. I start by attaching the upper front arm support to the radio tray. Next I screw the upper front arm onto the other end of the turnbuckles. Then I insert the cut down M3 62mm hex socket bolts. I then insert the threaded ends into the shock tower. I loosen the 4 screws that hold the front differential to the chassis. I do this to make slipping the radio tray into place a lot easier. Now that I have that back on, I can tighten the front differential screws. And now I screw in the 3mm grub screws that lock in the modified M3 62mm hex socket bolts. Now I screw on the M3 nuts and screw in all the remaining radio tray screws. After putting everything together, I notice that the newly installed upper front arms don't allow the body to sit flat. So I mark out some areas with a marker pen, then I use some small scissors to cut out those areas. Once I have cut them out, I simply wipe off the excess pen markings with a paper towel. And here it is with the upper front arms installed, and the Lexan body parts cut out. I printed them in grey PLA Plus because this is the only PLA Plus colour I had at the time. Maybe in the future I'll reprint them in black PLA Plus just for aesthetics, but I don't think it really matters. Plus it makes it clearer on what parts on the vehicle were actually modified. It all works very well, and there is no bound up tension in the way that I've screwed it all back together. It completely removes the play that was there originally. So now I guess there's only one thing to do, and that is to take it out and test it to see how it performs with its new modification. Okay, so here we are taking the car out for a test run. I won't be jumping it or doing extreme over-the-top things with it, but I will be testing how much more stable the steering is. Now, if you've ever operated a radio-controlled car on gravel, you will know that the car is quite unstable because it's almost like driving on marbles. So it actually takes a bit of skill to keep the car on track. So as you can see, I'm able to slide into a turn and power out with complete control, and that makes the whole project worthwhile. You would have a hard time operating a default HSP Xstr Pro on this type of surface. The precision that it has right now is absolutely incredible. I decided to create a 120 frames per second video to see what kind of action shot I could do. I filmed these videos using my phone that was attached to my head with my DIY phone head mount that I created in a previous video, and it seems to work very well. I really like how the car performs now, and with the custom DIY stainless steel skid plates I have on the bottom, I have no worries about stones scratching the plastic chassis. And as you can see, after the run, the 3D printed part held up quite well. Overall, I'm extremely impressed with how this modification turned out. So this brings us to the end of the video. If you liked this video, give it a thumbs up. If you didn't, give it a thumbs down. If you want to see more content like this, feel free to subscribe, and I'll see you in the next video.